Greetings everyone. Welcome back to my YouTube channel where I help students prepare for external examinations like IGCSE, WAEC and checkpoints. Today we're going to be looking at a topic that is in both WAEC and the IGCSE syllabi, and that is mesuration. But for today, we're going to be looking at questions from IGCSE past papers. So, are you ready? Get your papers, get your pen, and let's get started. Our first question says, the perimeter of a sector of a circle with radius 8 centimeters is 26 centimeters. Calculate the angle of this sector. So we're given the perimeter of a sector. Now in the first place, what part of a circle is called the sector? The sector of a circle is a part of the circle that is guided by two radii. So I have this as my sector. This is the radius, and this is the arc. So how do we find the perimeter of a sector? Remember, perimeter is the distance round a shape. So for this particular shape, since we have a radius here, we have a radius and an arc. So the perimeter would be the sum of the radii plus the length of the arc. And that is 26 centimeters according to the question. So we have our radius to be 8 centimeters. So this is 16 plus the length of the arc equals to 26. So that means the length of the arc is 26 minus 16. The length of the arc is 10. But we are looking for the angle. So what's the formula for calculating the length of an arc? The length of an arc is a part of the circumference of the circle. So that's theta out of 360 times 2 pi r equals to 10. So we are looking for theta. Theta over 360 times 2 pi times 8 equals to 10. So this will give us 8 will go in this ones. This is 45. So I have 2 pi theta over 45 equals to 10. So 2 pi theta equals to 450. I'll divide both sides by 2 pi, and that will give me the value of my theta. So you get your calculator and you divide. If you divide this, 450 divided by 2 pi. You can use the pi. You should actually use the pi in your calculator. So that would give us 71.6197, which is approximately 71.6 degrees. Okay, I hope that is clear. So let's move to the next question. I would like to change the color. Okay. All right, the next question says, Carlotta buys a bicycle. The diameter of each bicycle wheel is 46 centimeters. Carlotta rides the bicycle a distance of 1.4 kilometers. Calculate the number of complete revolutions that a wheel makes during this journey. So we need to find the number of complete revolutions. Now remember that when the bicycle wheel is moving, we're actually looking at the distance round the wheel, which is the same thing as the perimeter. So the first thing we need to find is the circumference of the wheel, which is the circumference of a circle. So the formula for calculating that is pi d. Since we're given the diameter, so we just use pi d, and that's going to give us 46 pi. Now, what this question is really asking us to do is to find a number of times that this wheel will move completely on a track of this distance. So we need to convert this to centimeters, and that will be 1.4 times 1000. This will take you to meters, times 100 will take you to centimeters. So for us to calculate the number of turns, we have 1.4 times 1000 times 100 divided by 46 pi. So get a calculator We have 1.4 times 1000 times 100 divided by 46 pi. And that would give us 968.7692. Now, at this stage, we need to conclude and ask ourselves, what will be the final answer? Are we going to approximate this to the nearest whole number, which will give us 969, or the answer will be 968? Well, the answer is going to be 968. Why? Because the question asks us for complete revolution. Complete revolution. So that means this bicycle wheel will complete 968 revolutions. Then there will still be a small distance that has not been covered. But because we are particular about the number of complete revolutions, so our answer is going to be 968 revolution. Okay, I hope that is clear. Let's move to the third question, which is going to be our last question for this short video. It's just a short video for today. So let's see. Let's read the question. A, B, C, D, E, F, G, H is a regular octagon with sides of length 6 centimeters. The diagram shows part of the octagon. O is the center of the octagon and M is the midpoint of AB. So our first question says, show that angle OAM is 67.5 degrees. Now, let's identify our angle OAM. So this is what we're looking at. But to show that that angle is 67.5. Now, the first thing we need to look out for or to calculate is the value of each angle of a regular octagon. So each angle of a regular octagon is n minus 2 times 180 divided by n. Now in this case our n is 8 because it's an octagon, so 8 minus 2 multiplied by 180 divided by 8. Now when you use your calculator, this is going to give us 45 degrees. So that means this angle here is 45 degrees, and that will make half of it, which is this 22.5. So with that, we'll note that we're going to note that angle OAM would be equals to 90 minus 22.5, and that's going to give us 67.5 degrees. The second part says, calculate the area of the octagon. Now, for us to calculate the area of the octagon, we need to first calculate the area of the triangle. We have a triangle here. We need to first calculate the area of the triangle. So we can either use 1/2 times base times height, or we use 1/2 AB sine theta. Now let's see which one will work best for us. If I'm to use half base times height, that means we need to find the height, which is OM. We need to find OM. So let's find OM. This is opposite. Using this angle, this is opposite, this is the adjacent. Okay, once we have that, we can deduce from here that our OM will be, this is, remember we're told that M is the midpoint, so this is 3. So we have tan 22.5 equals to opposite over OM. So OM is 3 divided by tan 22.5. So we get our calculator. Let's write it here. OM equals to 3 divided by tan 22.5. So we get our calculator. 3 divided by tan 22.5, and that gives us 7.2426. We're going to write this to 4 decimal places because we still need this value to calculate the next question. So now that we have done that, we have half times the base is 6 and the height is now 7.2426. So that would give us 21.7279, and that's the area of one of the triangles. Now if we decide to complete this diagram, remember this is the center, we decide to complete the diagram to have our octagon, you realize that we're going to have 8 identical triangles there. So we have to multiply this by 8 to find to get our final answer. So multiply by 8, and that's going to give us 173.8. So the answer is 173.8. It could also be written as 174 centimeters square to 3 significant figures. Right? Then B, find the area of the circle that passes through the vertices of the octagon. The area of the circle that passes through the vertices of the octagon. So let's go back to that shape. Now here I have my circle passing through the vertices of the octagon. It's going to look somewhat this way. So OB or OA, as the case may be, would actually be the radius. So we need to find the radius of that circle. So I'm going to bring out the small triangle. I have this, this, and this. We have calculated this part. This gave us 7.2426. This is the midpoint. This is M. This is 3. This is A, and this is O. So we can find OA. OA is the hypotenuse. This is the right angle. OA is 3 square plus 7.2426 square. That's OA square. So OA would be equals to the square root of this. So let's get our calculator. 3 square plus 7.2426 square. That would give us 61.4552. Then we find the square root of that. The square root of that is OA is 7.839. So that's the radius, 8393. That's the radius of the circle. So the area of the circle is pi r square. That's going to give us pi times 7.8393 squared. So multiply that, and we have 193.0673, and that's approximately 193 centimeters square. So that'll be all for today. I hope you're able to pick one or two things. I'll see you in my next video, and I wish you all the best in your forthcoming IGCSE examination. Bye for now.